the tricks that we learned for the radians in my previous videos and knowing what sine, cosine, tangent, secant, cotangent are for all of the radians in the first quadrant, you can get the rest of the unit circle. So we're just going to practice going through the wrapping functions, which is just the ordered pair. It goes cosine comma sine. So we're just going to go straight across. If you want to follow along, you can use a printout in the content library. And we're just going to go through all the tricks. So anything with a denominator of 3, I know that 1 plus 2 is 3. So therefore, 1/2 has to go first, followed by square root 3 over 2. However, 2 is 1 less than the denominator, so I know that that's in quadrant 2, which is negative positive. So I know that this is going to be negative positive. So we have negative 1/2 comma positive root 3 over 2. And the next one, 11 pi over 6. Looking at the denominator, I know that with a denominator of 6, square root 3 over 2 goes first because 3 times 2 is 6, followed by 1/2. The 11 means that it's going to be in the fourth quadrant where it's positive negative because 6 times 2 is 12 minus 1, 11. So we have positive negative. 3 pi over 2. So this is one of our halfway in betweens. The 3 is bigger, so I know that that is going to be on the axes down here. And we have 0, negative 1. Next one with a denominator of 3, 1/2 has to go first because 1 plus 2 is 3, followed by square root 3 over 2. With a numerator of 5, I know that that's double minus 1, so that has to be in the fourth quadrant where it's positive negative. 5 pi over 4, with a denominator of 4, that has to be 2 times 2 is 4, so square root 2 over 2, followed by, of course, root 2 over 2. With a numerator of 5, that's 1 more than the denominator, so that has to be in the third quadrant, negative negative. Pi over 2, so that's a halfway point. That's going to be halfway in between 0 and pi. It's going to be on the axes. So it's 0, comma 1. 0, again, on the axes, we begin at 0. So we have 1, comma 0. With a denominator of 3, I know 1 plus 2 is 3, so 1/2 has to go first, comma, followed by root 3 over 2. The 5 being larger, that's going to be in the fourth quadrant, so positive negative. 11 pi over 6. So now we're getting into repeats, which is okay, but we already found this answer. 5 pi over 6. We haven't done this one yet. So with the denominator of 6, I know that 3 times 2 is 6, so square root 3 over 2 has to go first, followed by 1/2. 5, it's 1 smaller than the denominator, so it's going to be in the second quadrant, negative positive. 5 pi over 4 we already found. Pi over 6 is one of our base ones. That's in the first quadrant. So we have 3 times 2 is 6, so square root 3 over 2 goes first, followed by 1/2. Positive, positive. Pi over 3, again, that's one of our base ones in the first quadrant. 1 plus 2 equals 3, so 1/2 has to go first. 2 pi, so we start at 0, but we end at 2 pi. So therefore, my answer on the axes, 0, 1. 4 pi over 3, so with a denominator of 3, we have 1/2 that goes first. 1 plus 2 is 3, followed by root 3 over 2. The numerator is bigger, 1 more than the denominator, so that's going to be in the third quadrant. So it's negative negative. Same answer. Same we already did. Pi over 4, that's one of our base ones. 2 times 2 is 4, so square root 2 over 2 goes first, followed by root 2 over 2. 3 pi over 4. So we have 2 times 2 is 4, so square root 2 over 2, comma root 2 over 2. The numerator is 1 smaller, so that's going to be in the second quadrant, negative positive. 7 pi over 6. So we have 3 times 2 is 6, so we have square root 3 over 2 going first. The numerator is 1 bigger, so therefore we have in the third quadrant, negative negative. 5 pi over 6. I believe we already did that one. Keep scrolling. 7 pi over 4, that's a good one. Let's skip over here. So denominator of 4, root 2 over 2, comma, root 2 over 2. This is going to be in the fourth quadrant because it's double minus 1, so we have positive, negative. Down to 4 pi over 3. So for 4 pi over 3, I know that 1/2 has to go first. 1 plus 2 is 3, followed by square root 3 over 2. Based on the numerator, this is 1 more than the denominator, so therefore it's in the third quadrant, negative, negative. Let's do 5 pi over 4. So again, 5 pi over 4, 2 times 2 is 4, so square root 2 over 2 is first and second. Based on the numerator, that's 1 more, so it's in the third quadrant, negative, negative. 7 pi over 4, this is double minus 1, so therefore it's in the fourth quadrant, positive, negative. So it's going to be positive square root 2 over 2, comma, negative square root 2 over 2. See, let's do 5 pi over 6. So I'm backing up a little bit. So for 5 pi over 6, denominator of 6, 3 times 2 is 6, so square root 3 over 2 goes first, followed by 1/2 second. This is going to be in the second quadrant because it's 1 less than the denominator, so it's negative, positive. Let's see. Let's do one more. Let's do 5 pi over 3. So for 5 pi over 3, with a denominator of 3, 1 plus 2 is 3, followed by square root 3 over 2. This is double minus 1, so therefore it has to be in the fourth quadrant. So it's going to be positive, negative. And those are some examples of the wrapping function. So again, the ordered pair, cosine, comma, sine, and that way you can find all of the other trig values, so sine, cosine, tangent, secant, cosecant, and cotangent, knowing what those ordered pairs are.